Kia ora, Year 11 and 12. This video is inspired by the trouble some of you were having to start with today in class with the trig integrals. So what I've decided to do is I'm taking question 8 from exercise 5b, which is an old exam question, but I've made it a step harder by taking away the trig identity, which gives you a really big clue. So this is the integral that I want you to try and find. So we're going to find the exact value of this thing here. So before you pause the video, let's just have a look at how we might attack this. So we've got this thing here, and we could expand it and then use some trig identities to try and simplify it. Now the reason we're going to have to do that is you'll find when you expand you have cos squareds and sine squareds, and we know that they aren't going to work out very nicely. Okay, so I want you to pause the video now and then do a little proof out, not a proof, but just a thing out the side here, where you take this expression and I want you to try to manipulate that into something you can easily integrate. So pause the video now and go ahead and do that. Okay, so hopefully you did something like this. Now some of you will have spotted that you can put this into r cos x minus alpha form or r sine blah 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 form. So that's one way that you can go here. It's not going to help you that much, because you're still going to have something squared. Okay, so that's not how I'd proceed. I'm sure some of you are going to tell me that you found a cool way to do that, and that's great, just leave me a comment. But what I would do here is I'd expand this out and I'd get cos squared x plus 6 cos x sine x plus 9 sine squared x. And then I'm going to work on this in 3 bits. The first thing that I'm going to do is to go back to AS and think about our very first trig identity, which was cos squared x plus sine squared x is equal to 1. So I'm going to take one of those out. So we've got cos squared x plus sine squared x. And then I'm going to look at this and say, well, that's to do with sine of 2x. Right, so sine of 2x is 2 cos x sine x. So this is going to give me 3 sine 2x, and then I've got 8 sine squared x still left in here. Okay, so when we do problems like this, we're usually not thinking of really difficult identities. We're using the basic ones as often as we can. And here we're now going to take this cos squared x plus sine squared x, and that works out to be 1. We can stop worrying about 3 sine 2x because we know that that's going to be really easy to integrate. The only thing we've got left to deal with is this 8 sine squared x. So how can I think about that? Well, I'm going to do a little bubble out to the side. And this is what we saw in class today, that the double angle formula for cosine is just so useful. So cos of 2x has one version, which is 1 minus 2 sine squared x. Right, and then there are the other two as well, but the one we're interested in here is the one that will help me get rid of the sine squared. And I want 8 sine squared x, so I'm not going to bother to find one of them. I'm going to now find that 2 sine squared x is equal to 1 minus cos 2x. Okay, so I'm going to use this to substitute in to 8 sine squared x. I'll just go back to the same pink pen so that you can see what's happening. So I'm now going to have 4 times 1 minus cos 2x. Right, so cleaning that up, I get 1 plus 3 sine 2x plus 4 minus 4 cos 2x, which simplifies to 5 plus 3 sine 2x minus 4 cos 2x. So what have I done? Well, I started out with an integral, right? So here's my integral, but I take one look at it and go, I can't integrate this as it stands. So I'm going to go and do a whole bunch of work to simplify this first before I start dealing with the integral sign. So now what I can say is that the integral between pi on 4 and 0 of cos x plus 3 sine x squared with respect to x is the same as this much nicer integral, 5 plus 3 sine 2x minus 4 cos 2x. dx. So now we're back to some basic trig integration. We just have to be careful with our coefficients. Right, what do we get? Right, so going term by term, when I integrate the 5, I get 5x. Now, the next one, what will differentiate to give me sine? Well, it'll be cosine. So it's going to be cos of 2x. Cosine differentiates to give me negative sine, but I want positive sine. So it's going to be minus 3 over 2. Right, one more time. This is happening because of the chain rule. When I differentiate this function, I'm going to get the cosine will differentiate to negative sine, 2x, but I then have to multiply through by the derivative of the inside function. So this divided by 2 here will undo that effect. Right, so that's the first bit there. And now what have I got? Well, I've got to do the same thing here. So what generates minus 4 cos 2x? Well, it's going to come from sine 2x, and it'll be minus 2, right? Because when I differentiate sine 2x, I'm going to get cos 2x times 2. And now I just have to evaluate that integral at the two limits, and we're going to use some absolute values. So you know that I'm going to draw a tiny bad graph here, right? There's my graph of the first bit of the cosine curve, of the sine curve, and of the cosine curve. So what have we got? Well, we've got 5 pi on 4 minus 3 over 2 times cos of pi on 2 minus 2 sine pi on 2 minus 0 minus 3 over 2 cos 0 minus 0. Right, I'm putting in the minus 0 here because sine of 0 is 0. It seems reasonable to go straight to that. Cleaning this up, what do we get? Well, we get 5 pi on 4 minus 0 minus 2 plus 3 over 2 because cos of 0 is 1. That gives me 5 pi on 4 minus 1/2. So there you go. Now that should hopefully give you a bit more confidence with the harder ones in exercise 5b. Remember, it's all about using your double angle formulae for the more complicated problems. If you were finding it really hard in class today, make sure that you've done two things. Do all of the really easy questions at the start of the exercise and go back to differentiation, because often when we have trouble with integration, it's because we're not differentiating very fluently yet. So either go to the Delta book or go on your least favourite thing, Education Perfect. Thanks for watching, and enjoy your day off tomorrow.